Hey, welcome to the lecture on the binomial distribution, the Excel version. So by now you've seen the binomial distribution and how it works and all of the foundational material that we need to know in order to apply a little bit of technology to it. So I think one thing that you could take away for sure from the binomial distribution is that the formula is a little labor intensive. And so we want to introduce a tool that's going to simplify the process for you. You still have to understand the output. You still have to understand the question, the context, and be able to apply your critical thinking to answer these questions. But what the technology is going to do for you is it's going to kind of quickly crunch out each individual probability. And so let's see that in action. Just remember that a binomial distribution is a fixed number of trials, typically the number n. We have two possible outcomes, success or failure, and then each trial that's repeated is independent and it has identical conditions. So you could think about this as rolling a single die 10 times. You could think about this as flipping a coin 13 times, whatever it is. So the first example, we're going to flip a fair coin 4 times and count the number of heads. So we said before our random variable X is going to be the number of heads after flipping 4 times. And we've seen it computed all of the different outcomes and then put into probability distribution table. We don't really need to do that this time. We're just going to identify n, the number of trials. So this is the number of trials. And for us, a trial is just a flip. So this is 4. Then we need the probability of success. On a single trial, which is to say the probability of getting heads on a single flip. And so for us, that's going to be 1 out of 2 or 1/2. Right? You get heads or tails, so it's 50-50. So now what we can do is we can actually go ahead and put this into Excel. So here I am in the distributions Excel workbook, and there are a bunch of tabs on the bottom. So you may have already seen the PDF for discrete random variables, and right next to that is going to be binomial distribution. So the number of trials was 4, hit enter. The probability of success was 1 out of 2, hit enter. And please make sure to only enter values in the highlighted purple areas. Only enter values in the highlighted purple areas. Everything else, I'm sure you noticed, let's do it again. Everything else populates based on whatever you put here. So when I put in 4, nothing happens. But when I complete the highlighted purple areas, everything else computes. What that tells you is that in all of these blank cells, there are formulas and witchery and magic that is happening. And if you write over them, like if you were to delete this cell, now all of a sudden your whole Excel sheet is not looking hot. So please do not erase the white or blank cells. Please do not write in or type in the white or blank cells. You will not have good mathematical results. If that happens and you are like, oh, I just ruined my Excel sheet. First of all, you're not alone. You're very not alone. You're in great company. Second of all, download a new sheet. Just download a new sheet, forget it, delete the old one, download a new one, and move on with your life. Okay. So what we've done here is we have computed all of the probabilities. So these numbers should look really similar to what we computed last time. And notice I'm just grabbing the first 2 columns right now on purpose. So this should look really similar to what we computed by hand in the previous lecture. And then we also have our histogram that automatically populates. So now I can grab a histogram. Wonderful. And it didn't take that long. You just have to identify the number of trials and the probability of success. So aside from the probability distribution, all of the probabilities 0 through 4 as we computed yesterday by hand, and aside from the histogram that is a result of the probability distribution, what else is on here? I think the first thing to know is that it's going to give you also the probability of failure, which we said was the opposite or the complement of the probability of success. So notice that you get the probability of failure. That's right here, probability of failure. You also get the mean. This is the same as the expected value. So we are now in a place where we use the terms mean and expected value interchangeably. And you're going to see questions on the homework that say, what's the mean of this random variable? And the very next question may say, what's the expected value of this random variable? They're asking you the same question. All right, we have variance. So variance is computed by NPQ. We went over this yesterday, and standard deviation is computed by the square root of the variance. And so that's why we have focus on the variance here. So in our class, we focus on mean and standard deviation. Standard deviation is the square root of the variance. And so I try to note that here through formula. We also have a third column in our output. And the third column, if I could move things around, is actually the cumulative probability. And notice there is the symbol less than or equal to there. We will do an example where we use that third column. But for right now, I just wanted to show you the outputs when we use Excel. All right, so let's actually do a full problem. This is a problem that we did in the previous lecture. We did it by hand. It was pretty tedious. So let's make some space and knock it out. In order to use Excel for any example, you always have to know your N, the number of trials, and you have to know your probability of success. Both of those are given to us here. This is a totally abstract example of a binomial distribution. No one's playing baseball, no one's flipping a coin. We're just given N and P. And frankly, I don't need a backstory to have fun with this. So 0.646. And notice that when I put those in, I'm seeing the numbers change. The last number in your list, and I'm looking here in Excel under the K column, the number of successes, the last number should always be the same as your trial size. So this is 5, my trial size is 5, so I'm feeling confident that this is I've hit enter at all the right times. Okay, so the first thing we're going to do is we're going to create a PDF. Guess what? It was done automatically for us. Here's our PDF. That is part A. Oops, not in highlighter. So I can check that off my list. The next thing I need to do is I need to create a histogram. Guess what? It was done for me by Excel. So here's part B. Part C, find the mean for the random variable. Part D, find the variance. And part E, find the standard deviation. Guess what? Those are all done for me right here in this upper box. So this was C. Variance was D here, and standard deviation was E. So now we've done all of those. So we're more than halfway done, and we kind of didn't do anything, which is great. We love Excel. Compute the probability of at least one success. Okay, so now we're going to really start using our knowledge about basic probability in conjunction with the output of the binomial distribution we have from Excel. So I'm going to grab our whole entire table, and we're going to work on F, at least one success. Make you a bit larger. So at least one success. So what would that look like? So this is F. There's two ways you can think about this. The first way is you can just say that is the same thing as one or more. So you could grab this plus this plus this plus this plus this, and then just add them all. Because at least one means one or more. And so if you do 0.0507 plus 0.1851, plus all this junk, then what you should get is 0.9944, roughly, should be the answer. Okay, cool. You could totally do that. There's another way to do at least one. So if I take this and let's do a repeat on F. I'm going to do it in green. So this is still F, at least one. And to me, at least one, another way you can think about it is it's not none. So it's the complement. That's the word not, the complement of the probability of getting 0. So in order to compute the complement, you just do 1 minus the probability that x was 0. So that is 1 minus 0.0054. And what I would get, and where did I get that 0.005? Oh, sorry, not 54. Excuse me. 56. And where did that come from? It came from right here, right? So these are the numbers of successes, and this is the probability associated to it. So this says 0 successes, that has probability of 0.0056. And so if I crunch this all out, I get 0.9944. I like this way. If this doesn't make sense to you intuitively and you like the pink version better, by all means, stick to the method that resonates and makes sense with you. All right, that was F. Let's go back up to G. Find the probability. I'm just going to copy these. Find the probability of no more than 3 successes. Okay, so maybe we can actually use this third column. So let's check out G. No more than 3 successes. So the third column is telling you if you were to add up all the probabilities up to that point. So for example, if you were to add up these 3 probabilities, 0.0056, 0.0507, 0.1851, what you would end up with is this sum right here. So that's what this cumulative third column is for. It's saying if you add up everything that's happened up to this point, that's what you get. And we know that that is the meaning of cumulative probability, or in particular, we saw it as cumulative frequency or cumulative relative frequency. Same idea. All right, find the probability of no more than 3 successes. So no more than 3. Can I include 3? Yes. I can be 0, I can be 1, I can be 2, or I can be 3. So what I could do is I could just add up these 4 values. I could definitely do that. But what I know is that if I add up these 4, it's the same as this number here. Burr, 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 burr. And that's your answer. Yay. All right, so there's G. Let's do H. Probability of 1 or 2 successes. This one is very straightforward. Capital P for probability, in parentheses, what's happening, probability of 1 or 2 successes. I need this guy and this guy. There's no fancy trickery here. I'm just going to add up these two numbers, 0.0507 plus 1851, 85320. Boom, there's your answer. Okay, 0.2358. And we have the probability of more than 1 success, but less than 4 successes. So let's see how that looks. So to say more than 1 means we're not going to include 1. We're definitely not going to include 0, but we're not going to include 1. Could we include 2? Yes. Can we include 3? Yes. And we need to be less than 4. So can we include 4? No, we have to be strictly less than it. And so you're just doing these 2 values. So this problem ends up being very much the same as the one that we just did. So 1851 plus 3378. I hope that's right. I have not had my coffee yet. But anyway, if that's the right sum, and I'm hoping it is, that's the answer. The method is to add up the probabilities individually. So when can you add up probabilities individually, and when can you use that third column? You can use that third column. The short and easy answer is when you're starting from probability 0 and summing all the way up to that point, starting from the beginning and going all the way up to that point, use that third column. If you're starting somewhere in the middle, just add them up individually. And if you really hate the third column, by God, you can add them up individually all day long. It is totally up to you. All right, so our next example is very straightforward, another abstract binomial distribution problem. And it's just asking us basically to do the same thing we've just done, but this time they're not giving it to us literally, they're giving it to us mathematically with symbols. So we're given n is 11, p is 0.5. We don't need the histogram. We don't need mean, variance, or standard deviation. It just wants to know, hey, what are the probabilities of these things? So I'm just going to steal the PDF with its cumulative third column, paste it over here, and let's see what we get. So for the first question here, probability that we have 5 successes, I'm looking here and I'm just straight taking this value, just a single probability, 0.2255, whatever. Now the probability that X is less than or equal to 5 means I actually want all of this, right? And so I said, when you're starting from the beginning and going all the way up to that point, boom, all the way here, you can just go ahead and use that third column because that totals it for you. But now in the third question, it's very similar, but we're just missing that little dash under the inequality. So that means that you can't go all the way up to 5. What it means is that you're going to go, you are starting from the beginning, but you're going to stop before you get to 5, meaning you're actually just going all the way up to 4. Well, guess what? You're still adding from the beginning. So you can definitely use that third column again. Oops. All right, and now for being greater than 5. This one's not very fun, but it's okay. So for greater than 5 means you cannot be 5, but you can be 6. And you're going to go all the way to the end. So you're going to use all of these. So you want to add up all of these guys here. And if you add them up, actually, you would get, let's say I've already done this behind the scenes because I'm recording a video. If you add all of these up, you're going to get 0.5. And then the last one we're going to do is x greater than or equal to 5. So let me just paste one more table here. And now this time, what color would you like to be? Last question. So greater than or equal to 5, now you're here. You're starting at 5, going all the way down. And so you're just doing the same thing. You're adding all of these up. The 0.2255, 0.2255, the 0.1611, 08, 026, 005, 0004, blah, blah, blah. Add all those. And what you're going to get is 0.925586. Sorry, 7292. And so that's how you can use the output from Excel to answer these questions. It's up to you to understand the symbols. We've already gone over the symbol notation and also the literal words that mean at most, greater than or equal to, all those sorts of things. So if you need a review on that, please do that because they're going to come up a lot for the rest of the semester. Okay, man with a deli. The owner of a small deli is trying to decide whether to discontinue selling magazines. He suspects that only 8.8% of his customers buy a magazine, and he thinks he might be able to use the display space to sell something more profitable. So he's going to track the number of customers, looking at the first 10 customers, and he's going to kind of do some math on that. So this is binomial. We need N and we need P. So how many customers is he tracking? 10. What's the probability of success? 8.8%. So you need to convert that into a decimal, 0.088. And the question is, what is the probability of exactly 2? So let's plug it in. We've got 10 customers. We've got 0.088 or 8.8% chance. And based on the output, probability that x equals 2 is right here. Okay, much faster with Excel. All right, next question. Let's see, suppose you take a 4-question multiple choice quiz where each question has 8 choices. Holy moly. Okay, and it's asking the probability. So each question has 8 choices. So what if you just randomly guess, what's the probability of being right when you have 8 options? It's just going to be 1 out of 8. How many times are you answering a question? 4 times. So that's your number of trials. You can put fractions into Excel and it'll just automatically convert it to a decimal for you. Okay, so now we have our output, our probability distribution. Okay, cool. So remember, K is going to be number correct, the number of successes. What is the probability of getting any question correct? What's the probability of success? This is just saying if on any question you were to guess, what is it? And it's just the probability of success. We already said it was 1/8, or as a decimal, 0.125. What is the probability of getting any question wrong? This is the probability of failure. And we said that probability of failure is just 1 minus the probability of success. But we also have it kind of thrown out in Excel for free. It even says probability failure. So it's here. What is the probability of getting 2 questions correct? So 2 questions correct is going to be going to where it says 2 and just looking at that value. 2 questions correct was 0.0718. What's the probability of getting 3 questions correct? Oh my God, the entertainment does not stop. Now, this last question is interesting. What's the probability of getting all 4 questions wrong? That means how many did you get right? If you got all of them wrong, you got 0. So this is the same as getting 0 correct. And so that would just be here. All right, so that's that problem. And I wanted to do one last, this one seems pretty straightforward, but the answer format is interesting. So let's do it really quickly. According to the American Red Cross, 10.7% of all Connecticut residents have type B blood. A random sample of 25 residents is taken. So here we're given N, here we're given P. Okay, so N, 25, P. Convert that percent to a decimal. And you'll see we get a pretty long list here, but I actually don't care about any of that because I just want to know what is the standard deviation. And what you'll see here in our output is that the standard deviation is given to us as 0.15, right? Here's, oopsies, here's our standard deviation. It's 0.15, da-da-da-da-da-da-da. That's not an answer choice for us. But what we have to appeal to is the fact that standard deviation is the square root of variance. So it's going to be the square root of our variance is the square root of 2.388775. Do we have that in our answer choice? Absolutely. Boom. So that's how you do that. Okay, I hope that helped enough to get you guys started on using Excel with the binomial distribution. I cannot recommend mastering this technology enough. We're going to be relying on Excel tremendously for the rest of the term. So please reach out for help as you need it.